Okay, today's lesson kind of springboard from our previous lesson where we talked about an angle in standard form. Theta I'm mapping here is 45 degrees. It's halfway in between our 0 and 90. This is our initial side, and this is our counter clockwise rotation, and then there's our terminal side. And then I could draw a second angle in standard position, again from the initial side, terminating in that same quadrant 1, but this time the measure of this angle is negative 315 degrees. Again, same initial side. But this time we are rotating clockwise. And the measure of the angle itself is not negative. The negative is used to indicate the direction of rotation. And in fact, these two angles are coterminal angles. Coterminal angles are angles that share the same terminal side. If we look at our example here, these two angles, we put them on the same coordinate plane, they would map to that same terminal side of the angle. I could find another angle coterminal with 45 degrees by just adding 360 to it. So 45 and 405 are also coterminal angles. Okay, our first example, we are asked to find the smallest, so not just any, but the smallest non-negative angle that is coterminal with 580 degrees. The first thing we want to look at is we want to compare 580, the given angle, to our reference, which would be 360 degrees. And since 580, the one we're trying to have the same terminal side with, is greater than 360, our result is going to be to subtract the 360 from the 580. And we will get our 220, which is less than 360, means it is the smallest angle that is coterminal with the 580. Next, we're asked to find the smallest non-negative angle that is coterminal with negative 203 degrees. We've got our negative, but again, we're not really, the negative means the direction. So we're going to consider the absolute value of the 230, which this time is less than 360. So we're just going to add that negative 230 to positive 360 to get the answer to the question, which is positive 130 degrees. This time we're being asked to find smallest non-negative angle that coincides, which means the same thing, coterminal. Coincides is a vocabulary word we had when we were solving systems of equations and we would get an infinite number of solutions. That's because the two lines that we graphed are really the same line. And we said those lines coincide. And this time we want to coincide with an angle that measures 13/3 of a pi. So now we're talking about our radian measure. And in this instance, it might be helpful to take that improper fraction and think of it as a mixed number. So this would be 4 and 1/3 pi, which is clearly greater than 2 pi, or in the previous two examples, 360. And in fact, we want to narrow that interval down a little bit more. 4 and 1/3 pi is greater than 2 pi's, but less than 6. So we can go twice around, but not 3 times around. And so now we're going to, because we're larger, we're going to take away 2 revolutions to get to the smallest coterminal angle. Taking away a 4 pi here, which would leave us just with 1/3 of a pi, or we could say pi over 3. Okay, we'll look at another one here. I need the smallest non-negative angle that is coterminal with negative 7/4 of pi. So again, we're going to consider the absolute value of this, because the negative just indicates direction of rotation. And now we can clearly see, and using our mixed number instead of our improper fraction, that this angle rotates less than once around the unit circle. So what we could do, like we did with the degrees, when we have the negative degrees, we're going to take our negative 7/4 of a pi and add it to 8/4 of a pi, or 2 pi's, ending up with a pi over 4. Here they ask, what is the smallest? Again, they're not just asking for any, they're being specific for the smallest. And we're talking non-negative angle that coincides with negative 21/6 of a pi. So again, we're looking at the absolute value of this. And this is going to be, you might want to think of it as a mixed number. and that's clearly more than 2 pi's. And so we need to go ahead and add 2 pi to the negative because we're in between 2 pi and 4 pi. So we take our negative 7/2 pi. I'll just reduce that fraction and add it to 2 pi's. And we end up with pi over 2. So we can make some general rules here. For a negative angle measure, we add 2 pi to produce an angle that is between 0 and 2 pi. For positive angles, for positive angle measure, what we're going to do is subtract 2 pi to produce an angle that is between 0 and 2. One last thing to talk about would be converting between degrees and radians. So we want to recall 1 revolution, or once around the unit, a circle is 360 degrees, which is equivalent to 1 revolution, being talked about as measured in 2 pi radians. Here we have equivalent fractions with equivalent numerators, which implies that the denominators also are equal. And now we can reduce this relationship and distill it down to 180 degrees are equivalent to pi radians, which is one of the conversion factors we're going to use. Or we could say that 1 radian is equal to 180 over pi, which would be about 57.298 degrees. All right, so we'll do a couple of examples of converting here. We need the number of degrees in 1.9 radians. So we start with 1.9 radians. We use the conversion that pi radians is the same as 180 degrees. We see the radians divide out. We get our calculator to work the math to get our approximation, and that's a little over 108 degrees. We need the number of degrees in pi over 3 radians. We start with pi over 3 radians. We use our conversion factor. 1 radian is equivalent to 180 degrees. And we divide out the pi's, the radians, and reduce 180 over 3 to get 60 degrees. And if we wanted to know what 1 degree was equivalent to, we would have 360 is equivalent to 2 pi radians. We would divide by 360 this time to have that 1 degree is equivalent to pi over 180 radians. And last example, how many radians in 350 degrees? We start with our degrees and we use our 180 degrees maps to pi radians. Our degrees will divide out, and we can reduce this fraction to 7/4